video, we're going to be talking about modules. Now, one of the reasons that Python is a very powerful language is that many people have written add-ons to the basic programming language that do all sorts of useful things. And those things are things like visualization, data analysis, working with the World Wide Web, manipulating images, and even controlling Lego robots. This is great because since other people have written it, you can use all of this functionality for free. Module is a way for Python to bundle together a set of several functions and statements, and then import these modules into programs and use them to do all sorts of really useful things. A module is usually made up of a set of tools that are used for a single type of task, for example, manipulating images. So we're going to talk about two specific modules in this video, the Python math module and the matplotlib pyplot module. So we're going to get started by talking about the math module. The math module is exactly what it sounds like. It's a module that has all sorts of useful functions like sine, cosine, and so on that are standard mathematical operations. One way to access the math module is by typing import math and then hitting Shift-Enter. And then once you have that, you can then call the various functions that are in the math module like this. So for example, if we want to take the log base 10 of 200, we type math.log10 200, and it gives us a value. It also has constants like pi. So for example, we can type math.pi, and sure enough, we see pi. And it also can do conversions. For example, you can convert from radians to degrees. So let's say we want to go from pi over 2 radians and find out how many degrees that is. We can type math.degrees and then say math.pi divided by 2.0. And 90 degrees. Pi over 2 is 90 degrees. You can also find out quite a bit about the math library by just typing help, which is a function that's built into Python, and then math, because we've imported that math module, and then hit Shift-Enter. And then the Jupyter Notebook does something really interesting. So let's go ahead and just hit Shift-Enter. And what you can see, and now I'm going to scroll down and we can look at this, is that what this has brought up is a huge thing of documentation on the math module. And it tells you lots of stuff about the module, about all of the different functions that are available, and some other things about different pieces of information about the math library. And this is true for all modules that are callable from Python. You can generally use this help function to find out about them. And then you can go ahead and just get rid of that by deleting it, hitting Shift-Enter, and it goes away. Another incredibly useful package that we're going to be talking about is matplotlib. So you can find that at matplotlib.org, and it's built into your Python distribution. Matplotlib is a Python library for making high-quality figures of various types. You can do things like line plots, scatter plots, histograms, bar charts, and so on. It's very, very useful. You can also control the features of the plots. You can change line styles and fonts and colors and axes and all sorts of things like that. We'll be using lots of the functionality of matplotlib during this course. Let's go ahead and actually do an example of this. So coming back to our notebook, I'm going to import part of matplotlib. So I am going to type something slightly different than before. I'm going to say import matplotlib.pyplot as plt. So what I'm doing is I'm taking matplotlib, which is the overall library, and I'm importing a sub-module of it, or a sub-library called pyplot. So I'm just pulling in part of matplotlib. Then what I'm doing is saying, give me this big long string, matplotlib.pyplot, give it to me, and let's call it plt. So let's go ahead and go back to our notebook and do a demonstration. So what I'm going to do is type import matplotlib.pyplot as plt. And what this does is it imports the matplotlib submodule. So it's not bringing in all of matplotlib. It's bringing in just a piece of it called pyplot. And what it's going to do is name it PLT. So what we're doing is we're saying bring this thing in, import it into our notebook, and call it, the as part means call it PLT. And the reason we're doing that is for convenience, because this matplotlib.pyplot is very cumbersome to write. So then the second thing we're going to do is type %, and then matplotlib inline. And now we hit Shift Enter. And this second line, this %, matplotlib inline, allows us to display images within the IPython notebook itself. All right, so now we're going to go ahead and make an actual plot. So we're going to type in plt.plot. And that's just the standard two-dimensional plotting package used by pyplot. And so we open up parentheses because this is a function, and we give it a list. And we're going to give it a list of values. And we're going to say it's 1, 5, 2, 3, 0. And then we hit Shift Enter. And it creates an image for us, or a figure, really. And you'll notice that the x-axis goes from 0 to 4, and the y-axis goes from 0 to 5. And that's because if you just give the plot, plt.plot, a list, what it'll do is it'll assume that those are the y-axis values, and it'll just assign the x-axis values just from 0 to whatever the end is, all by itself. And so you can see that the first value is 1, then it goes up to 5, down to 2, back up to 3, and down to 0. So how can we change that? We can feed in a second array of values. So for example, let's just say I want 15231 or 230 to be my y-axis values, and I want to add x-axis values. So now what I'll do is I'll put a new list in, and put in the list first because it's x, y, and let's say we want to make it 0.5, 1, 2.5, 3, 3.1. And so I have the same number of values. I have to have the same number of values. And now I hit Shift Enter again. And now what you see is that the y-axis values are all the same. But now, since I've fed it x-axis values to go along with the y-axis values, it's changed the shape of the plot. And in this list, the first element in the x list is assumed to go along with the first element in the y list. And the second one in the x list is assumed to go with the second one in the y list, and so on. And I have a tremendous amount of flexibility about what I do with this plotting package. Now, I can change the color of the lines. So, for example, I've given this list of x positions and the list of y positions, and then what I do is follow it with a bunch of strings, or a string that says what color I want. So I can put R for red, and now it gives me a red line instead of a blue line. I can furthermore say, instead of a solid line, I want a dashed line. So I put in the code for dashed line, and there's documentation that explains this in matplotlib, and we'll provide you with links for that. And so if I hit Shift Enter again, sure enough, it's a dashed line. And then let's say, instead of just doing a dashed line, I want to get rid of the dashed line, and what I really want to do is just put circles in. So I put in, get rid of the dash dash, and put in an O, hit Shift Enter, and there I go. I have circles. Now, as you can see, we've done something kind of unfortunate. We've made it so that it's really hard to see the points that are around the edges of the plot. So what we can do is go back up here, go to where it says plt.plot, all the stuff, hit Enter, and now what we can do is start modifying the plot. So we can change the axes by typing plt.axis, and we put in another list. And the list is the beginning and ending in the x dimension and in the y dimension. So let's just say we want to go from 0 to 4 in the x dimension and -1 to 6 in the y dimension. So 0, 4, so it's x begin, x end, comma, -1, comma, 6. And now we hit Shift Enter. And now as you'll see, the bounds of the figure, so where it starts and ends in the x dimension and in the y dimension, have now stopped, or have now changed, I'm sorry. And we can actually do some other things to make our lives easier. As you might imagine, it can get really cumbersome to type in these lists. So what we could do is say xvals equals, make a list and call it xvals, and then I'll make a list called yvals. And you can call these whatever you want, of course. You can put these up here, and now replace where those lists were in the plt.plot function, xvals and yvals. And so if we hit Shift Enter, nothing should change in the plot. And in fact, nothing does change in the plot. So now we can also further further modify the plot by adding more sets of values. So for example, we can we'll make something called xvals2, and we'll give that values of 1, 2, 3, 4, and we'll call it yvals2, and we'll also just give it 1, 2, 3, 4, and that should just go in a diagonal line across the screen. And so now I'm going to modify plt.plot to just add an extra value. So we're going to say xvals2, yvals2, and then let's make this line a blue dashed line. So it's b dash dash. And so now on top of all these red points, we should get a blue dashed line. So I'm going to hit Shift Enter, and there we go. We get a blue dashed line that goes 1, 2, 3, 4. And if I wanted to make that a different symbol, so let's say I want to make it x's instead of a dashed line, I just do bx, hit Shift Enter, and we get the points. And now right here where the cursor is, one of my red dots is now overlaid with a blue X as well. And I could keep putting more and more sets of values in here, or by calling plt.plot several times in a row and overlay all sorts of stuff on top of here. And so this is one of the ways that this plot function, the plt.plot function, is extremely powerful. Now what we're going to do is modify the plot a little bit more. So I want to go back to having lines. So I'm going to make my red line solid and my blue line dashed. There we go. And so what I want to do is actually make the line widths thicker. So what I'll do is I'll just say line width equals 3 and just add that at the end of my big chain of x value, y value, color and line type, another x value, another y value, another color and line type. And so I just want to make the lines a little bit thicker. So now I'm going to hit Shift Enter, and as you can see, the lines have all gotten thicker. So I want to make this plot even more customized. So what I want to do is add some titles. So I'll do plt.title, and let's just give it a clever title. And what I want to do is give it some X label. So let's just say time, and a Y label. So plt.y label, and well, we'll just call it some values. And now I hit Shift Enter, and now what I have is a figure that has a title up on the top here, a label on the x-axis, and a label on the y-axis. And in these calls to the title, x label, and y label function, I could even go further and tell it what font to use, how large I want the font to be, and more things about the shape. There's lots and lots of different ways to modify these types of functions. And then the final thing, of course, is to save the figure, because we have a figure that we're happy with, and we want to save it for posterity. We don't want it just in our IPython notebook. We want to be able to send it home to our parents so they can print it out and put it on the fridge. So now what we're going to do is save the figure by using plt.savefig, and then in the function call, we give it the name of the figure. And so what I'm going to call it is my first figure.png, and a PNG is a type of file, and so a type of image file. And so now I type Shift Enter, and if I go and look in the directory where this IPython notebook exists, then what I'm going to do is I'll find that figure called myfirstfigure.png. And if I change the file name to something else, like PDF, it'll save it as a PDF instead of a PNG. Or I could save it as a JPEG or various other file types. So matplotlib is smart enough to know. All right, so what have we learned? Let's go to Markdown here. So what have we learned? We have learned that people have written all sorts of useful tools for Python. And those do all sorts of different things. They do visualization, they do data manipulation, they work with the web, control robots, etc., etc. So modules are a way to access this. To access these tools by typing import and then the name of the module name. Or a variant of that, like with pyplot, it's import matplotlib.pyplot as PLT. Now, we also talked about the math library and pyplot, and so the Python math module and matplotlib.pyplot are two really powerful examples of Python modules. And we're going to be using them quite a bit in this class. And also, particularly when it comes to pyplot, pyplot is a really useful module that lets us make and modify figures in all sorts of ways. And that's what we've done today. Thank you very much.